Let me just, I know we happy autumnal equinox, if you will. So I thought, let me get a picture because we also had a new moon that kind of fell right at the same time as the equinox, right? A day later, or whatever, before. So I'm like, let me go outside and get a shot of the moon. But I cannot do that because it's 7:57 p.m. and the moon set at all of 6 minutes ago. It was only at 1.4% illumination, so it would have been kind of pretty, but no moon for me. Let's see what else we got. Now, this is news to me. A good time for aurora chasers. I didn't even know that was a thing. When did that become a thing? This week around the September equinox, we were expected to see a boost in auroral activity. Oh, really? Really?
Equinox and solar maximum. Why auroras are about to surge.
Are they? I didn't know.
Published by Time and Date. Skywatchers may be entering one of the best times in years to see auroras, thanks to interesting effects that kick in around the equinox. Aurora
Hold
chasers.
up. First and foremost, this is not a time of year. What did she just say? It doesn't matter. There has never been a time in all of history where around the equinox it was time to chase and or look for auroras. Let me just please make that very clear. We have times of the year where it's more you're more apt to see a shooting star or aka a meteor because we're having a freaking meteor shower. But that Skywatchers may be entering one of the best times in years. Like this has happened before. Maybe it has, but that was a reset before now. To see auroras, thanks to interesting effects that kick in around the equinox. Okay.
Could be in for a treat this month.
Are we?
As the September equinox approaches, two key phenomena, the
happened.
Russell-McFerrin effect and the equinoctial effect,
we'd have to look into who is Russell.
Expected to boost auroral activity in the coming weeks. Why the equinox sparks auroras.
Yeah, why?
At the equinoxes, Earth's axis is tilted neither toward nor away from the sun. This geometry shapes how Earth's magnetic field interacts with the solar wind. Earth's magnetic field points north, and when the solar wind's magnetic field points...
I will say that the sun and moon have been rising as far north and northeast as possible. There we go.
Southward, opposite to Earth's, the two fields can connect, a process called magnetic reconnection. This process lets energy and charged particles from the sun stream into Earth's magnetosphere, powering auroras.
Interesting.
Think of it like two magnets. If their poles are opposite, they snap together. If they're the same, they push apart. Around the equinoxes, Earth's tilt positions its magnetic field so that we more often experience the solar wind's magnetic field pointing southward, opposite Earth's, allowing the two fields to connect. Even when the solar wind's magnetic field isn't southward, auroras can still occur, though they tend to be stronger and more frequent.
No shit, Sherlock.
When the field points south, opposite to Earth's. Because this alignment happens more often around the equinoxes, auroras in both hemispheres become brighter and more frequent. This phenomenon is known as the Russell-McFerrin effect. The equinoctial effect. Scientists point out that another factor...
Is that even a word? Like, how long is that? Let's find out. Define. Like, happening at or near the time of an equinox. Okay. Back to the fake and gay of it all. Oh, damn. For real. For real, though.
Equinox and solar maximum. Why auroras are about geometry and magnetic fields. Even when the solar wind's magnetic field isn't southward, auroras can still occur, though they tend to be stronger and more frequent when the field points south, opposite to Earth's. Because this alignment happens more often around the equinoxes, auroras in both hemispheres become brighter and more frequent. This phenomenon is known as the Russell-McFerrin effect. The equinoctial effect. Scientists point out that another factor, called the equinoctial effect, also boosts auroras. Around the equinoxes, when Earth's tilt is effectively zero relative to the Sun, our planet's magnetic poles fall nearly at right angles to the solar wind. This orientation makes Earth's magnetic...
Briefly, I've been hearing about this 0-degree energy, and then I just watched something on nuclear, what have you, which seems to be some baloney in my opinion. I mean, how did they even take those pictures? Cameras would not have allowed for that to even happen. Like these Hiroshima or this or that. I'm not saying it didn't happen. I'm saying it didn't happen like they said it did.
Sphere.
Oh, the 0 point. Yeah. So that's a thing with like setting bombs off, as well as the etheric energy in the atmosphere that should be free. None of us should be stressing or paying or worrying about paying a freaking electric or gas bill to heat our home or have the lights on. Just saying.
Planet's invisible shield, more open to interactions with the solar wind.
Now, in regard to the magnetosphere, I see that all the time in the sky. Like every sunrise, every sunset, there are like rainbow waves, if you will. Like, and they're not always this rainbowy, but either way, I can see it in the film, in the camera. That was white, you couldn't really see that. But you'll see these arches at sunrise or sunset,
allowing energy and charged particles to enter. Our in-house astrophysicist, Dr. Renata Malin-Huss, explains how this essentially makes our magnetosphere a bigger target for incoming solar wind.
What?
The equinoctial and Russell-McFerrin effects are neat interplays between geometry and magnetic fields.
When did this happen?
When they coincide at the equinox, the night sky can put on some of the most memorable auroral shows of the year.
Well, all right.
Some scientists also point to a third, weaker component called the axial effect. It relates to Earth's position relative to the Sun's equator, which may also play a small role in boosting auroral activity around the equinoxes. Solar maximum, an extra boost. This year, the timing is especially favorable. The Sun seems to be just past the peak of its solar maximum phase, the period in the 11-year solar cycle, when solar storms and Earth's geomagnetic activity are stronger and more frequent. These storms can produce both coronal mass ejections, CMEs, and faster, denser solar wind, supercharging the northern and southern lights. The combination of solar maximum and the September equinox gives skywatchers one of the best chances to see auroras in over a decade. When and where to see?
Yeah, when?
For aurora hunters, this combination of factors means the weeks around the September 22nd equinox are prime time for auroral viewing. Geomagnetic storms are still required to create visible displays further from the polar regions, but the odds are tipped in favor of more frequent and brighter aurora displays around this time of year. The Northern Lights. In the Northern Hemisphere, the next several weeks could bring ideal viewing conditions for high-latitude regions such as Alaska, Canada, Scandinavia, and the northern parts of the UK. Strong solar storms can cause the northern lights to light up skies much further from the usual auroral zones, sometimes as far south as the northern US or Central Europe.
You might want to check out
the Southern Lights. In the Southern Hemisphere, the aurora australis can be visible from Tasmania, New Zealand, southern parts of South America, and occasionally even South Australia during strong geomagnetic storms.
That's crazy.
Fewer people live under the southern auroral oval, the area around the poles that usually gets the aurora, but those who do may enjoy darker skies and less light pollution, making the equinox boost especially rewarding. Don't miss it.
Yeah, of course.
Around the equinox, when Earth's tilt is effectively zero relative to the Sun, the alignment of Earth's magnetic field and the Sun's extended magnetic field can make auroras brighter and more frequent across the globe. Combined with the heightened activity around solar maximum, this means that whether you live under the auroral oval or farther afield, this could be one of the best times in years to witness nature's incredible light show.
Made it sound kind of like we're under a dome.
Frequently asked questions.
All right, we're good. So basically tomorrow would be a good time to see the moon, the very small moon with the maybe with Venus. Like I caught it the other morning rising. I'm curious to when it'll be like that setting. And since this won't open, let's see. So you might be able to catch Venus around a little bit ago. I mean Mercury. Venus rise and set in Tampa. Because what time is the sun coming up? Nobody will tell us. Oh, 7:18. And Venus is rising at what time? 5:21. So you can see it. Yeah, it used to be visible in the daytime. It did used to be visible in the daytime. It no longer really is. Mars is already setting, or it will be. It's 8:08, it sets at 8:52. Jupiter rising before sunrise at 2:01 a.m. So for Venus and Jupiter, did you have just been, like, I don't know, 2 weeks ago? Or right next to each other, maybe 3 tops? And then now they got this big old gap. That's because Venus moves a lot faster. Saturn rising and setting. Is it already going down? Up almost all night. So it rises at what time? 7:20. So Saturn is just coming up right now. Matter of fact, we could probably see it. And now, mind you, Uranus and Neptune are out there also. Neptune and Saturn, by the way, been right on top of each other. Let's see. Neptune is rising at 7:26, and what did I just say about that? 3 minutes apart. So anybody in their natal chart, your Saturn and Neptune, well, they're conjunct right now. So depending on where they are in your chart, they're probably being triggered. But everybody was talking about this planet parade or planet alignment back in like January 2025. And the planets are always in a line, if you will, along the ecliptic. They're just not usually all visible in the sky. And right now, pretty much they are. Let's see. Mercury, difficult to see. That's most of the year. Venus, fairly good visibility. Mars, slightly difficult to see. Jupiter, fairly good visibility. I would say it's really good. Saturn, perfect visibility. Uranus, average. And Neptune, well, yeah, you would need something to help you see it, but aside from that. So, like, can I see the freaking map? Now, this is interesting because we just found out a moment ago that the moon set at 7:51 p.m. today. But tomorrow, it's going to be a whole hour later. Or it'll rise at 8:51 and it'll set whenever the heck it sets. Here we go. So, like, let's see for the month. It's quite a bit different. So every day it's like an hour, give or take. Different. I don't know why that is. Is that just me that's weird too? I don't know, but okay, so over these next couple days, tomorrow it will set at, okay, so if it's set at 7:51 today, tomorrow it's going to set at 8:19, the moon. But then look, 8:19, but then the following day, 8:50. So that's like, I don't know, 30 minutes. But then the following day, it's gonna 33 minutes. Then 10:02. Then 10:45. So literally 43 minutes. Then 11:34. That's like 45 minutes, give or take. And on the 29th, where'd the moon go that day? I mean, why is it blank? What's up with that? Oh, because it sets it. I see. It, like, as soon as it becomes midnight. So on the 29th, the moon does not set. It just rises at 2:21 p.m. Sets at 12:29. It's all so crazy. This is where I want to get. I literally just asked it, when will the moon and Venus be next to each other, setting in the sky? And they come back at me with the moon and Venus last appeared together, setting on the evening. You're not even making sense, of September 19th in the eastern pre-dawn sky, not setting. So why do you say they were setting? I don't know. They are now a significant distance apart, with Venus still visible as a morning star. For future opportunities, you wanted to check. Well, that's why I was asking you. Just saying. Yeah, this was really beautiful. I caught this the other day. And I didn't even know that it was happening. So I just happened to go out there. It was quite nice. So the trio rose together around 4:30 a.m. I have a telescope, but I need a better lens, I think. Shortly after the 20th, that's my mother's birthday, Saturn's moon Titan transits the ringed, almost said worm, world alongside its shadow, the second to last shadow transit we will see for more than a decade. Oh, I didn't even know this happened. The event starts around 12:30 on. That's interesting, because I was looking for Saturn that morning and I couldn't see it. I could not see it. Huh. Interesting. Well, at that time, Saturn stands some 40 degrees higher in the southeast. And east is up, located to the lower left of the circlet in Pisces. The planet is the brightest point of light in that region of the sky. Zoom in on Saturn with a telescope and you'll see 8th magnitude Titan approaching the planet's northeastern limb shortly before 12:30 midnight. Okay, I missed that. It crosses in front of the disk. Yeah, I would have needed a telescope anyway. I'm just like one of those things. Can I see what it is today then? What is it? The 23rd already, though? Isn't it? Isn't it? It is. Or maybe it's the 22nd. I don't know. Yes, summer's over. The autumnal equinox also officially brings the northern hemisphere's summer to an end and begins astronomical autumn, while bringing the end of winter in the southern hemisphere, beginning astronomical spring. One of autumn's showpiece objects is the double cluster in Perseus, the 2-for-1 deal. There's a ton of double stars in that area. Comprises open clusters NGC 869 and NGC 884, which lie about half a degree apart in northwestern Perseus. To find them, look about 4.5 degrees west-northwest of 4th magnitude Eta Persei. This region is 40 degrees high in the northeast, around 10 p.m. local daylight. I wouldn't say that's daylight. Both clusters glow around 4th magnitude and cover half a degree each. You can view them together at a low power binoculars or something dark side. Saturn and Neptune reach opposition. The outer planets are at their best as Earth marks the autumnal equinox and the Sun undergoes a partial eclipse visible in New Zealand, Australia, and Antarctica this week. Both eclipses, by the way, crossed right over Antarctica. Saturn and Neptune both reach opposition, but they're right next to each other. So opposition makes it sound like they're opposite, but they're not. They're directly next to each other. I heard about this. It wasn't visible from where I am, but on Friday, September 19th, the moon passes 0.8 degrees north of Venus and 1.3 north of the magnitude 1.4 star Regulus at 8 a.m. Eastern while Venus passes. The point was, not from Florida or the U.S., but other places, the moon occulted or eclipsed Venus out for a short time. Interesting stuff, kind of. Yes, indeed. Okay. So there's basically your cosmic update. All right. Have a good one.